sitting at each vertex. 1 iota times E is sitting at each vertex. Okay? This is a coupling strength. So what is the coupling strength? Just in the most layman language. I have this in the earlier, this can work as my coupling. I can take two different threads and I can hang them here. Okay, blue and red. I can hang three threads or 4 threads. Okay, but if I don't have this, how do I hang them? So this is coupling them. Okay, a peg. Right? You have something to where you can hang your things. I have some threads of different colors, or one shirt, one sweatshirt, one something trouser or something. I can hang them there on that. Unless I have that, I can't do it. Okay, I can't do it in here. No, I need something. So we are here together. We are being coupled through this lecture course. Yes, you are here to listen to me. I am here to tell you something. So we are coupled. Yes, it's the same coupling. So E 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. So these are, for example, all the possible diagrams of the. This is second order. This is fourth order. Then you can have e to the power 6. This E is nothing but lambda. And An. So for example, for An, for this there is only one diagram, Feynman diagram, which contributes to this. For e to the power 4, when n is 4, there are 1, 2, 3, 4, 5, 6, 7 these diagrams. Okay, I can construct many more. Just make use of these 3, and you can construct as many as you like e to the power 6. Try to see which ones are allowed, which ones are not. You will see it. Just very simple practice. And you can also do it on some other process. For example, so what is this? This is Compton scattering. Okay, and this is second order. 1E. This is second order Compton scattering. Okay, and I can introduce this here or here or here, or I can introduce here or I can introduce here. Right? So, and what else? Oh, I can introduce this here. Right? I can introduce it here. Is that correct? So you got higher order diagrams. And so, and you know that this E is a very tiny thing, very small coupling. Okay? So actually what happens, the strength of a force varies according to the distance or the energies. And this is a great outcome of quantum field theory, which tells that the strength of a force varies according to the distance or energy, and this is the coupling constant. So coupling constants can vary. Okay, this is the major outcome of field theory. Now, if you do all this and you use the regularization and renormalization theories using this context, and you can find a sensible number here using this. So right now I'm not going into the details of this. I do it at Delhi University in quantum field theory 2 course, lecture course. Okay, but here you will find something finite, and that's good, very good. If I would do a similar thing in gravity theory, I would get something absurd. If I would do it in gravity theory, how would I do gravity theory? For doing gravity, I would replace this by a graviton. Okay, this is a photon. So replace all of them, and how do I do it? So this is a diagram. By the way, conventionally, a gluon and a graviton, they are shown by the same spiraling line, but we are not doing any QCD theory here, so if I make this, you can assume that this is a graviton. Okay, so this is a graviton, and then I would have all these diagrams. And so on. Okay, all of them just replace the photon. This is a photon. This is a photon. Photon by replace a photon by graviton, and you are doing gravity theory. Okay. Now this would not be E, little e, but some coupling constant for the gravity theory. Okay. And if you do these things, doesn't matter whether you do higher order things or not. Just even if you do the lowest order diagram, which is called as a tree level diagram. Okay. Lowest order diagram, then the transition amplitude here is infinite. If you calculate the transition amplitude for this process, any of these processes, counterpart that you know in the simplest field theory, which is QED. QED is your simple field theory. If you replace your photon by a graviton and redo the things and do so for the gravity theory. And now if you calculate, whether you calculate so this is a Compton scattering where it's a graviton, electron, 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 graviton. So Compton scattering in gravity theory. Okay? Just do the lowest order diagram, calculate it, and the transition amplitude you will get is infinite. Okay? And if we try to know why this happens and how to resolve this process, we immediately